after the walking session that you guys did, must be a bit charged up. I hope you find this session interesting. Uh, I'll start off with my session. Firstly, my name is Arvind Gopalakrishnan. I am the Chief Software and Information and Technology Officer for Sun Mobility. I will be walking you through and talk about how AI is being used in EV charging infrastructure. Before moving into what EV charging infrastructure is, how and what components of AI we are using as part of the use cases that we are trying to solve. Uh, I would just like to first quickly touch upon about what Sun Mobility is. So, Sun Mobility is a EV energy company, mainly into the swapping business. So we are a EV energy swapping company. It was founded in 2017 and is a joint venture between Many Group and Sun Group. Many Group, if you are aware and know, that was the pioneer in coming out with EV cars. So Reva was the first car that came out in India. If anyone has it, I would like to know. Can people raise their hand? Does anyone know about Reva? So it's not new, uh, but things have moved on from there, and uh, everyone started producing different types of electric vehicles. That is where uh, the company thought of going and building out the EV battery charging and swapping infrastructure, and that is what we do. We have actually tied up uh, with, we have a joint venture with Indian Oil, which is one of the largest joint ventures with Indian Oil in India. And the aim is to scale and grow the EV swapping business. On board, we have other key energy and other global giants on board, like Bosch and Vitol. These are some of the key investors on board. Uh, we have really grown our infrastructure by leaps and bounds from the time we started. Today, we have more than 1,000 swap points across the country and also more than 60,000 vehicles on the platform. And we are growing year on year in this business. As just a brief about me, I have been associated with vehicle, uh, connected vehicles and EV for the last 10 years. I have been associated with Dell prior to that and was developing products at Dell. In terms of the, in terms of using AI and cyber security, been doing it for the last, I would say 6 to 7 years. We have worked on a lot of use cases in the current and the previous organizations. I have been associated with developing multiple products and platforms, and that is the core that I build out and take it out. Uh, Clearly, my passion is towards building sustainable energy, and so uh, energy and ESG is a key area of my interest and work that I spend a lot of time in addition to AI and cybersecurity. Before moving into the AI part, I just want to spend some time on what are the core components of EV charging infrastructure. Firstly, to start off with, there are two types of charging. One is fixed charging and another one is swapping. Uh, as far as fixed charging is concerned, you have the core is around the actual chargers, which are the high power DC chargers, and uh, they actually deliver up to 350 kilowatt of power. Then you have the power electronics, which is really to ensure that there is safe and efficient energy flow that is happening as the charging is happening. There are specific communication protocols like OC, PP and ISO 5118 that enable seamless interaction between the chargers, vehicles and the grid. So if you look at a charging infrastructure, you have the vehicle which is getting charged, and then you have the grids which is supplying the energy to charge it. So the seamless integration is made possible through these communication protocols. The grid itself is critical uh, from an I mean, both grid and energy management is critical to run this operation really effectively. And we have to look at efficient ways to really optimize the usage of energy. There are many use cases. I'm not going to go into the fixed charging use cases today. And finally, you have the user interfaces and the payment gateways that enable the end customer to be able to use the fixed charges and be able to charge their vehicles and make the payments and then walk away. So that is on the fixed charging infrastructure. Coming to what we do, which is our core, we are a swap charging player. This is an alternative to the fixed charging fixed charging technology. Uh, the advantage is that instead of waiting for you to be able to charge the vehicle and keep waiting for the charging to happening, you are going to get a instant refueling of your energy. So the core components are the swapping station, the battery, which is going to go into the vehicle. Swapping means you are actually exchanging your battery, which is ready to use, with a battery that has been discharged. So like you exchange your fuel, you are going to be exchanging the battery. So that is what is the swapping concept. The battery itself is getting charged in the swap charging station. Now again, there are two types of charging stations. One is a manual charging station and another one is an automated robotic based charging station. Uh, in addition to these two, again you have the end customers. The battery is a smart battery. When you look at swapping, the big part is around enabling the battery to be smart so that you can track the battery when it is inside the vehicle, unlike in fixed charging where the chargers are used to charge the battery then and there. So, to manage the battery, the vehicle, and the station, which is the core components of the EV infrastructure, a lot of intelligence has to be brought into uh, the entire ecosystem. The infrastructure itself is made up of multiple uh, stations that are connected with each other. And if you go through Bangalore, you might find a lot of sites where there are one swapping station, or you may find sites where there are multiple swapping stations. So we have to cater to very complex use cases where there are multiple charging stations delivering to the same, charging and swapping process. The delivery of the batteries is happening through the logistics and supply chain direct into the stations. And so that part is also part of the overall infrastructure. So if you put it all together in a nutshell, you have the batteries, the customers who are doing the swapping, the stations, and the logistics and supply chain, all these put together form the infrastructure elements of a swapping network. Uh, Now coming to the AI part of it, which is what we are here for. Uh, if you see, I did a lot of research and thought through how do I take this and talk about what is actually really happening in the AI space. There is a framework called Kuthut framework. I hope I pronounce it right. So the whole journey goes through actually anyone adopting AI has to go through multiple phases. The first phase is really about selecting the right hardware and edge technology. Okay. The second phase is about looking at uh, how do I adopt it at the edge devices? The third phase is about bringing in AI applications into your ecosystem. And the last phase is about making and adopting AI into the physical devices. Why I'm talking about this is because in our AI journey, we are exactly going through the same phases, and I'm sure that as end enterprises will use it, they will also go through the same journey. So I just thought of introducing this framework to the people here. And I also wanted to start off before dwelling into the use cases that we are using for the infra AI use cases into what are some of the architectures that we are using at Sun as part of the AI solutions we are building out. So we are definitely using the traditional ML architectures. We have also adopting uh, deep learning architectures, models and frameworks. And we are also into the Gen AI models and framework. Uh, we handle a lot of data. So from that perspective, the selection of architecture is key across the different use cases that we look at. Uh, some of the examples I have put out there are about how we are using transformers to analyze the sequential data like battery usage, how we are using graphical neural networks to optimize the uh, routing and predictive uh, failures in our stations. And then how, and the other example is about using RNNs and LSTMs, forecasting traffic and battery behavior or state of health over the time. This, along with the other architectural models and frameworks, are the core thought process in how we are building out AI as part of the journey. So we divided the thing for the infrastructure side into three basic core problems. The first one is how do we enhance the core operations of the uh, infrastructure and how do we support field operations. The second part is that once we have looked at the core operations and infrastructure, how are we looking at uh, really automating and optimizing our backend using AI again, and what is it that we are going to look at supporting the backend operations to make the decisions. The final piece of the puzzle is because it's about infrastructure, it's always about the interactions of the human uh, with the infrastructure. So, how human centric AI and what AI use cases we have to work with people and then with experiences that the people are getting or the customers are getting with the infrastructure that they are interacting. So I'll be dwelling more into these use cases a bit for today. Coming first into the use case around the operational use case Uh, the first part is around using Edge ML socks. If you are aware of what Edge ML sock is, it's ML on it's ML on silicon chips. Really, I mean, there's a lot of work that is happening with companies like SEMA AI, Qualcomm, NVIDIA, etc., who are working at the edge, building AI into the SOCs and enabling critical decision making and inference making. The advantage is that instead of taking the data to the cloud, processing it there, and then making decisions, you're actually taking the decision at the edge level itself. This actually helps in reducing the latency, also enables privacy, and most importantly, it enables you to make real-time decisions, especially with things like image enhancement, object detection, etc. The primary use case there is about theft detection that I put there, but there are a lot more other use cases that can be looked at. The reason why we need this is because we run the operations nearly unmanned. So we have to detect theft and be able to make real-time decisions on theft and fraud, especially using video. So that is why this is a critical piece of the technology that is required to enable decision making and processing at the edge level. The other part of the operational use case is around prediction and assurance platforms. I have put down there multiple use cases, but clearly the most important ones I want to highlight is the predictive maintenance use cases that are critical to identify component failures. Again, I'm not going to go into all the different algorithms and models that we are using there, but clearly, predictive maintenance is critical for our operation, so we have to work on that in a very big way. Then the other use case is around the inventory optimization, which ensures that we are able to fulfill the battery availability as and when needed. So it is about real-time inventory uh, and inventory management and real-time battery issuance and tracking. We use clustering and Bayesian methods to help to understand user behavior and access and also assess the reliability around the uh, operations that we are doing. So that is about the predictive and assurance platform that we have. Since at the infrastructure level, grid is one of the critical components which is delivering the power to the charging station. Uh, we have to understand the energy demand. We have to be able to forecast for energy failures. And we also need to be able to support vehicle, I mean, uh, working with the grid, especially in case of fixed charging infrastructure. So vehicle to grid systems and managing dynamic workloads for both forecasting and higher energy availability are critical use cases in our intelligent and uh, grid and sustainability platforms. The another interesting use case is around dynamic pricing. Uh, I'm not going to go into more details on that. The uh, we talked about the operation side. Now I'll quickly run through the back-end automation use cases. So we are using agentic AI platforms to automate our backends. And in addition to that, we are literally taking our entire uh, business processes and automating them through AI use cases and models. Finally, we are using the backend side for simulation and forecasting. Lastly, I want to spend a couple of minutes on the human-centric AI use cases. So, clearly, there are a lot of use cases that or platforms that are required for it. The first one is around theft and fraud detection platform. Not because of lack of time, I'm not going to go through and read through the entire thing. The other platforms that we are working out are on the connected experience platform, the conversation intelligence platform, which is powered by LLMs, and then finally, I want to talk about some of the challenges and future directions that we really need to look at an overall level. One is about data fragmentation, standardization, privacy and cybersecurity, and autonomous charging. So these are some of the work that we are working towards from a future perspective, which is critical to our industry as a whole and critical to looking at how we incorporate AI into our day-to-day business use cases. So I just wanted to thank you for the time, and I hope you enjoyed it.